All right, welcome back to Mr. P Helps with Algebra 2. This is Unit 2, Topic 1, SLT number 6. We're going to once again get into more multiplication of complex numbers. And as you can see, I've done some examples for the warm-up. First, outer, inner, last, FOIL method. So I used first, outers. I multiplied these two, then these two, and then these two to get these four terms. I then combined the two like terms on the inside to get 32i. And then I also simplified the I squared to negative 1, and that basically changes this number to the opposite. So negative 16 became positive 16. And then I was able to combine this like term to this one. So 16 plus this other real number, negative 12, made positive 4. And then you can't combine a real number with a pure imaginary number, so that is the complex solution. And it's the same process for the other three questions, as you can see. So things that came first in their parentheses, and then things that are on the outside, things that are on the inside, and things that come last. I'll do more examples later on, as you will see. So we are, once again, adding, subtracting, and multiplying complex numbers and using the properties of operations. So what is this equation? So I, we talked about, is I. I squared is negative 1. And I the third is negative I, and let me just put all of these in parentheses. I, the fourth power, is positive 1. Now, negative 1 and positive 1, if you add them together, they are opposites of each other. They add up to nothing. I and negative I are also nothing. So when you add up all these numbers, these all add up to nothing. Nothing is the answer, believe it or not. So this is another way of solving it. So using the properties we can justify of commutative property, associative property, and distributive property, we can then justify all the steps that we are doing when we're adding and subtracting. So this is something I probably showed in class. This is just another method. It's not the way I prefer in order to prove it, but it is good for justifying as to the reason why you're doing what you're doing. So it's, in other words, what it does is it commutes, it puts the two terms that are together, the two terms that are like terms together so that you can combine those two like terms, and then also put these two real terms together. So you're grouping them together and you're commuting them. You're also moving them. So it's also, it's showing you basically the reasons and the steps of why you're doing what you're doing. So when you're subtracting, so you have to combine like terms. So there's multiple ways you can do this. I know in the last video I showed a different way, so I'm going to show the other method this time. So I'm going to show you how to set it up vertically instead of going horizontally. 2b minus a b makes b, and 6 minus 5 makes 1. There we go. 6h minus 7, and we're, oh, sorry, this is multiplication, not subtraction. Got to be careful. So that's first, outer, inner, last, just like the warm-up. 6h times 2h is 12h squared. Outer, 6h times 3 is 18h. Inners is negative 14h, and last, negative 7 times 3 is negative 21. All right, so 12h squared can't do anything with it, but we do have these two like terms in the middle. 18 minus 14 is positive 4h's, minus 21, and that's your final solution. You cannot combine any of these three terms because they are all not alike. One's an h squared, one's an h, and one doesn't have anything. All right, so this question is pretty much the exact same process, so I'll kind of skip that for the second. Actually, no, I'm going to show it. And the reason why I'm going to show it is because I want you to see something that you're going to be doing in the future. And we're going to be talking about when you have a complex and times complex. Well, when you notice these have the exact same numbers, but one's negative and one's positive. So let's see what happens when we do that. 2x times 2x is 4x squared. The outers is 6x. The inners is negative 6x. And the last is negative 9. Now what you notice happened when you have two things that are exactly the same, only it's differences of squares, meaning one's positive and one's negative, is that the two inner terms will always cancel each other out. And that's going to happen later when we start getting into doing the exact same thing with imaginary numbers. So two complex numbers doesn't always have to be it does always have to be a complex solution, but it can be a real solution, is what we'll find out later. All right, so same thing with complex numbers. 3 times 2 is 6. 3 times 5i is 15i. Inners is 8i's. And last is 20i squareds. Now, I know I showed this in the last video, so if you need more examples, I'm not going to do all of the multiplications. Oh, no, I need to backtrack because I just now realized this is not even a multiplication question, which brings me to my next point. You always, with this mistake, you always need to check, be careful, And notice which operation that you are dealing with. This is not a multiplication, this is an addition question. So I'm going to combine like terms. 3 plus 2 is 5. 4i plus another 5i's makes 9i. It's just like the example I had done before. The other way you could also do these is by setting them up vertically, like such. 3 plus 1 is 4. Negative 6i plus negative 2i is negative 8i. So just another way of doing the exact same thing. So these are going to be all subtraction. So 3 minus 2 is 1, and 4 minus 5i is negative 1i. You can do this also vertically if you're subtracting. So that's 3 minus 2i. 1 minus 3 is negative 2, and negative 6i's minus negative 2i's, which is really negative 6 plus 2, which is negative 4 times I. All right, so now in multiplication, 3 times 2 is 6. 3 times 5, so that's outers, is 15i. Inners is 8i. And last, 4 times 5 is 20i squareds. Okay, so 6 is a real term, can't do anything with it. 15 plus 8 more i's makes 23 i's. And remember, I squared is negative 1, so that changes 20 to negative 20. Now you've got two real terms that can be combined. So that combines to negative 14 plus the 23i, and you have a complex solution. All right, plenty of examples there. I think I'm just going to stick to one of each of these. So it looks like we have addition, subtraction, and multiplication. So this is addition. So I'm going to show setting up vertically again, since I haven't showed that a whole lot in my videos, even though I've been doing this concept for 2 videos now. 2 plus 2 is 4. Negative 4i's plus another 4i's makes nothing. So anytime you're adding the opposites of each other, that is your solution right there. It's just 4. Notice, once again, we have 2 that are the exact same brackets. That's what this homework was designed to do, is to show you how you're going to notice that everything's always the same, but one's addition, one's subtraction. Here, this one's addition, this one's subtraction. So it's been reversed. Instead, the additions came first. And then for this one, I guess it just switches up the numbers on the last one. All right, so 2 minus 4i minus 2 plus 4i. 2 minus 2 is nothing. Negative 4i's minus 4 more i's makes negative 8i's. There's your solution. Don't even need that 0. First, outer, inner, last. So 4, 8i. The inners is negative 8i, and last is negative 16i squared. Well, the 2 inners and outers cancel each other out. That becomes a 4. This turns negative 16 to positive 16, and 20 is your answer. This is one of those perfect examples of when we had a complex times another complex number, and it equaled a real solution. So all you have to do to make a complex times a complex make a real solution is by basically make the numbers exactly the same and make one negative and one positive. All right, please give it a like to help you learn something about multiplying, adding, and subtracting complex numbers. Plus, we got into this whole concept of, when the numbers are the same, how a complex times a complex could actually be a real solution. Thanks again for watching. Have a wonderful day.